Today's lesson is about confidence intervals for the mean. Okay, our particular examples in this unit will be when the standard deviation is known, or your sample size n is greater than or equal to 30. We can use the standard normal rules for our confidence interval. Okay, so first of all, you'll hear, talk, or read about a point estimate for the mean. Okay, so all a point estimate is it is a numerical estimate of a parameter. Okay, remember, a parameter is just some kind of a population, mean, median, mode, that sort of thing. Okay, so with that said, we can say that the point estimate of mu, which is your population mean, is going to be the sample mean. Okay, so a point estimate for the population mean is the sample mean. All right, so I guess we could say it this way too, that sample measures estimate population measures. Okay, so like we've talked about previously, if you sample something, you're using that to make some kind of a prediction or an estimate on those actual population values. Okay, so next up we have three properties of a good estimator. Okay, so in other words, what makes a good estimator? Well, one thing is it's unbiased. Okay, so it doesn't favor anything one way or the other. It just plays fair. Okay, unbiased estimator. So the mean, pardon me. The mean of estimates, or the mean of estimates from sample to population. Okay. Second one is it's a consistent estimator. Okay, consistent estimator. Okay, in fact, as sample size increases, the value of the estimate will get closer and closer, or approaches your parameter. Okay, so as the sample size gets higher, the value of your estimate, the sample mean, or whatever it is you're looking at, gets closer to the population mean, is what we're saying. Okay, and lastly, they want to say it has to be relatively efficient. Okay, relatively efficient estimator. Okay, so in other words, it has a small variance. Okay, and there's a little bit of theory and rules there that we won't be getting real deep into, but I wanted to at least mention some of that stuff. Okay, next we have what we call an interval estimate. Okay, an interval estimate, and we're just going to say this is going to be a range of values used to estimate the parameter. Okay, so it's a range, okay, where you think that your, let's say, population mean is going to fall into. Between two values, where is it going to live? Okay, so then a couple things. We have a confidence interval. Okay, confidence interval is a specific interval estimate of a parameter determined by using data obtained from a sample and a specific confidence level of the estimate. Then we have confidence level of an interval estimate of a parameter is the probability that the interval estimate will contain the parameter. Okay, so we have a confidence interval, which is what we're really going to focus on, and then the confidence level. So that's how confident you want to be. All right, so maybe kind of a side note here, the more confident you want to be about your estimate, the wider the interval will be, because you want to make sure that your estimated mean falls in that given range. Okay. All right, so we've got three common, I'll slide this up just a bit. Okay, confidence intervals, we have three common measures: the 90, the 95, and the 99% values. Okay, so if we used our standard normal table, okay, in our given situation, we're going to be using some z values to help us. Okay, and it looks like when I imported this, we got a couple little funny pieces here. All right, so why don't I rewrite this? Okay, so the central limits theorem says about 95% of the sample mean will fall within 1.96 standard errors of the mean. All right, so let's just kind of cross this out. What should be written there is that the mean plus or minus 1.96 times the standard deviation over the square root of the sample size is going to give us a given range or a confidence interval. Okay, so for a specific sample mean, okay, I'm going to put an X bar there, there exists a probability that the mean will fall in this range. Okay, plus or minus the square root of sample size. Okay, so a couple things that are going to happen. If we have a 95% or 90%, our critical value from our z's and central limit theorem, 1.65. Okay, sometimes you'll see it go a little more accurate, 1.645. 95% gives us this critical value of 1.96, and then 99% gives us that value 2.58. Okay, and if we talk about alpha, okay, in a given situation, that's going to give us the total area or total of the areas in both tails. Okay, so again, we're like this. Alpha is a total area in the tails. Okay. All right, so then we pick up a formula for your confidence interval. Okay, depending on the alpha level. All right, so this guy, in fact, let's just make this so it stands out. You're going to do X bar minus Z alpha over 2. That's your critical value, times sigma over the square root of n. You're going to put the mean in the middle, okay, and then less than the exact same sentence with a plus sign. So we're coming up with a range to create our interval. Okay, so now that we've talked about all of this stuff, what else should I mention here? Maybe if we read something about the maximum error of estimate, that's always this part that you're adding and subtracting. So it's sort of like how close you're willing to be. Your maximum error of estimate. Okay, or sometimes we'll refer to that as the margin of error. I guess that's probably how I'm more likely to say it. Okay. All right, so let's look at a little sample problem here. It says the president of a university wishes to estimate the average age of students enrolled. From past studies, the standard deviation is 2 years. A sample of 50 students is selected with a mean of 23.2. Find the 95% confidence interval of the population mean. All right, so what do we know? Okay, we need to know n. N is your sample size, okay? In this case, 50. The sample mean, okay? From past studies, the mean is 23.2. Okay, and then the Standard deviation should be in here somewhere. From past studies, the standard deviation is 2 years. There it is. Okay. All right, so do we know the standard deviation? Yes. Do you have sample size, so I'll put this aside, is n greater than or equal to 30? Okay, and you will say yes to that, okay, because our n is actually 50, okay. Do we know the z alpha over 2 level that we want? Okay, well, let's see here. Somewhere it gives us the percent. Ah, voila, there it is. 95% confident. Okay, so if we want to be 95% confident, our z alpha over 2 level is 1.96. Okay. All right, so let's do our interval. So we'll start with 23.2. Okay, so we're using the formula up here in red. 23.2 minus 1.96 times 2 over the square root of 50. Okay, then the mean's going to fall in between, so less than the mean, less than, same sentence with a plus sign. Okay, 2 over the square root of 50. Okay, so then if you do a little calculation, comes out 22.6 is less than the population mean, less than 23.8. Okay, so what in the world does that even tell us? Well, it means with 95% confidence, okay, with 95% confidence, the president of this university can say that the average age of his students, just trying to write this so you can have it if you want to read it again. Average age of his students is between 22.6 years and 23.8 years. Okay, so that he's 95% confident the age of those, average age of the kids is between 22.6 and 23.8 years old. Okay, all right, well, there's a brief introduction to confidence intervals for the mean, and put that formula on your formula sheet, and I'll see you soon.